My name is Tomas Gustafsson. I'm in Finland. I'm going to tell you a bit about working code. Usually I have slides, and this time I don't have a single one. I'm trying to keep an eye on the panel, but please interrupt anytime, either by voice or by typing. I'm going to tell you about 3D graphics, and I'm going to show you a bit of code. All right. First of all, let's start with sharing this screen. Number 3. Share. All right. I show you recent news in the Finnish broadcasting companies net pages. Yeah, that is the Finnish Lifeboat Association in the city of Vaasa in Finland, and they have built an entire cockpit of the patrol vessel 3, and they are, you may see this thing here, they are using stuff that are Stormwind controllers, and also part of my job is playing around with funny things like this steering wheel here. These are both actually designed by me and a friend of mine, and we produce them, so to say, because you cannot buy them on the market. A bit of fun with those. So I'm talking about 3D, and you all know that there are a lot of games on the market, and game engines like CryEngine, Unreal Engine. They're called Ogre, Unity, Irrlicht, Java 3D, for example. And I'm using one that many of you have seen before. It's a bit old, unfortunately, hasn't been updated too much lately. And it is written by a French guy, Sylvain Dupont, who is also running the weather site meteocl.fr. And you may have read in newspapers lately that there was a fire in Paris, I think, at the OVH ISP's data center. And Sylvain told me that they had 16 servers, of which 4 survived the fire. And of course, he didn't have too much of backup copies. Among others, the licensing server for the 3D engine was totally destroyed, and there is no solution for it at the moment. But I intend to distribute an APL workspace where there are a couple of samples of how you use the 3D engine. I need to resolve how to actually do the distribution, if I can give out the engine as well. Let's see, ask dialogue in a week or so. Structure on hard disk. Well, you have a workspace and you have a 3D engine. The 3D engine is one single file, a DLL, .NET assembly. And that is all. It's great in my opinion. There are not a million files spread out all over the hard disk, and half of them you don't know what they are there for. I like to know what I have, and I like to know why it's there. So it's very, very convenient for maintenance to have only one file for a 3D engine, and it's even not too big. It's middleware between APL and DirectX, so it is Windows, of course. And APL accesses, it's a .NET framework. So we talk about accessing our .NET commands. Simple and fairly good to maintain. What do I use to have a look at the DLL? I use RemoteSoft.NET Explorer, which shows it's old freeware. There are certain much better software available as well. But here you can see a bit of, this part is small font. I cannot increase that, but these are the elements inside the engine called TV engine or TV mesh or TV physics scheme and so on, mass library. And inside you can see the methods. This engine only has methods, no properties, so everything happens over a method call. And they have what we call them overloads. Many of them, most of them have overloads, and some of them are customized for taking APL arguments, because one problem with the rest of the world is that they like these structures, like here you can see a TV3D vector, or if you want, well, that's three numbers. We don't like to embed three numbers into an object. That's only three numbers, what the hell? Or colors. And if you want to send a million 3D vectors to middleware, you don't like to create a million objects and pass those. Instead, you like to send 3 million numbers in a long vector. So some of them are made for me in this engine. I complained about it being too slow with the other style, and there are some X functions. It's very, very fast. Sylvain is one of the most intelligent persons I know of in this life. So he has done a great job, but he's unfortunately moved on to a bit of other things. Here we have some of the Stormwind users. Many of you, of course, know that there's a boating simulator called Stormwind. I will show you it a bit later on. But while Martin was talking, I tried to, from my head, plot out some of the places where it is in use. And the big crosses here are rescue departments. I think there are 11 different cities who have Stormwind. Many of those have shore, nearby shore. And each of those have several fire stations. For example, in the Finnish capital, Helsinki, the Helsinki Rescue Department is using Stormwind to train their personnel in moving on the sea with a fast boats. And they have 5 fire stations around Helsinki with the Stormwind installations. The big black crosses are fire departments. The blue cross here is the police school, who also has Stormwind. So the red crosses are marine military defense forces at a couple of places. Also the Naval Academy outside Helsinki is a storm user. Then there are smaller cruises are Finnish Lifeboat Association, sub associations, of which there are much more than I have actually plotted out. Then there are all the other users, which I don't have inside my head, but it has spread out quite well in Finland, even without any marketing. Only thing I've ever done is participating in the boat shows in Helsinki, international boat shows, but otherwise it has kind of just passed on from mouth to mouth. I don't know how. So I have a workspace here, which I showed you on hard disk. Many of you may know that I like a very clear coding environment. I like to keep the APL household clear, and I hate leaving random data in the workspace hanging around without really knowing why it's there. It's a typical problem for APL coders is that according to what I know, but not necessarily for everyone, but I've seen many workspaces where there's lots of stuff, unaccounted stuff hanging around, and it's so easy to just save it and deliver it to the user. That's not how I do. So I want to know exactly what I have and why I have it here. If you can see this Explorer tree here, I have 4 namespaces, sim 1, sim 2, 3, 4, which are samples of using the 3D engine. And then there's this M namespace space with three dynamic functions. And the TV, it's for loading and unloading the 3D engine, named TrueVision 3D. And then I have shader namespaces with the code for the GPU shaders. That's a language called high-level shading language, which is a Microsoft thing. It's a C-style language with which you can create programs, shaders for the graphics card. And those I pre-compile into a namespace called shader. So this is basically what I have. And when I start the program, for example, now I'm going to start the sample in sim 1. It's going to create this function here. Let's walk through a bit. So when the whole thing starts, it's going to create in the Stormwind simulator several namespaces, but here one namespace called hash.sim. And from now on, everything is going to happen inside that namespace. All data is going to be created inside there, and all calculations are going to happen there. Once the simulator or whatever happens is shut down, it's going to clear out everything and delete hash.sim. And I will be back to the stage, the same environment, the same clear environment I am in right now before starting it. So I can run it and terminate it and save it, and it's always ready to go into production, basically. I don't know how the other APL coders do it, but that's, I think, a very good system. Initiating some dynamic functions like linear interpolation, inverse linear interpolation, normalize length of a vector, like you can see here, omega squared, and the sum of omega squared and the square root of that. degrees to radians and radians to degrees. Wherever I can, I type out the number instead of typing the APL symbol for getting P, for example, because I believe it's faster. And ByRef, APL ByRef. Right. Loading the 3D engine. You can see this one creates, this is the only other namespace it creates actually in addition to hash.sim. It will create the hash.t namespaces for the 3D engine. Usings, of course, in production you need to get the hard disk scan path and so on correct, but this is a bit hard coded. The engine is here, mtv3d65.dll, version 8 of it apparently. Then some Microsoft things here. Create a form, new form, and jump into that space directly. Morten told me long ago that do not use with and end, because it's clumsy inside the interpreter, and he was very much right. The CS, quad CS, is extremely fast. It's really something that people should use whenever needing performance and things happening elsewhere. So we change space to the for1 namespace and get along with a bit of shorter expressions. So here is a long strand assignment. Show the form and change space back. Change to the TV engine. This is, we need to walk through a couple of initialization things in order to set up the engine environment. Angle system, vertical sync, things like that, display frame rate in the upper left corner, back. Init the engine, create a scheme object, create a camera object, create an input object, initialize it, create a texture factory. It's a bit of a naive name, but it manages textures. The global namespace contains important things. Write in text into a screen, create this one. Then a couple of additional functions related to the yellow is created using these globals, and there is an RGBA namespaces function inside that. Red, green, blue, and alpha transparency. So I get a color object, which I use here in creating a font and creating a function that I can use, consume later on. Draw 32 yellow uses that font and the color. A bit related to 2D graphics, math library, vector 4 and matrix 4 shortcuts. Then here is a bit of APL mumbo jumbo. To load the shader into the GPU, you need to you want to avoid reading it from a file on disk. Instead, you want to keep it as an APL precompiled binary object, because APL is so great at carrying on all kind of data. So you precompile while you develop, because when you have the application in production, you want to be fast, so you don't want to compile anything any longer. And the compilation of shader HLSL code happens using a Microsoft compiler, an exe file, which one can call with CMD, quad CMD, and get a reply result in a file, and then you read that result and put it somewhere in the APL namespaces. At runtime, you do some mumbo jumbo with APL global alloc and global lock memory, and copy it and get it into the engine this way without having to do any disk work or work on hard disk. So that's load process. It pretty much has to be done this way, and there are a couple of steps to go through. Now, if you want to do a game, you know there are maybe a steering wheel and handles and joysticks and keyboard and lots of user action compared to most other programs. And a 3D application is always in a loop. It's a loop that goes on as long as the game or the simulation is in action. And between painting on the screen, there is time to read the keyboard. So this is well, we pre-create things. A biref, which is a pointer to a piece of memory, and that pointer we can give to the 3D engine. Once we ask the 3D engine to do some work, it may use that pointer to fill in the result. And that result we can, from APL, call read with refKeyData.value. So we create a piece of data for the keyboard input and another for the keyboard input. Then we create an APL variable with 256 slots for the keyboard keys, of which there are 256. A bit of housekeeping for Control Alt and Shift states, and define. There are two types of events in a game. You may keep your shift down all time and press arrow up, for example, if you want to run fast, and arrow up without shift maybe walk. So there are keys that are down all time or for longer periods of times, and there are keys that produce one event, but you don't want them to repeat. For example, if you press one enter, but you are a bit too slow with lifting your hand off the key, you don't want to produce two enters anyway. And so we need to control that with code and define which keys are those that maybe have a meaning when they are down longer time. These two are apparently here arrow left and arrow right. Then callback functions for the press once keys. This one callback function is very simple. It only analyzes key number one, which is escape in this simple case. And once the user presses escape, what happens is that it writes a 0 into something called hash.sim.run. That's just a variable that is either 1 or 0. As long as it is 1, the loop is going to go on. So it's a while run loop, and as run turns into 0, it's going to abort the loop and exit the simulation. And then for state keys, I seem to have two here, left arrow and right arrow, which writes a couple of values into two variables. So you don't do anything more once you get something from the keyboard. You just mark things. And then later on in the loop, you actually check what are the states of these variables. You don't take any action, any other action at this point. It's very important in looping. Then what I wanted to do, I wanted to create the simplest of all cases. When talking about 3D, that's a triangle. What do we have here? These are called, this is a vertex. So there are three vertices in a triangle. Everything is in 3D is made out of triangles. All 3D models are triangulated. It's a very good shape. This is, the lines are edges, and the triangle itself, the surface, is a face. So doing a triangle. Again, in practically all functions, the very first line is change space to hash.sim. It's mandatory. Then we started to create vertices. And the triangle, well, how do you define a triangle? There are 120 degrees. If you have the center point here, you walk around the circle with 120 degrees intervals and take sinus and cosinus, of course. So from right to left, 90 plus 120 times 0, 1, 2. Change that to radians with the dynamic function degrees to radians, and take cosinus and sinus and transpose it because it comes in the wrong way. Now you have a table with 3 rows and 2 columns, which will correspond to X and Y. 3D is X, Y set. And when I stand outside, I imagine that X is towards east, towards Russia. Y is up because we are used to have Y up. And Z is towards the North Pole. It's called the right-handed system, I think, yeah, where you point in with your 3 fingers in directions. So positive Z is towards the North Pole. Positive X is towards Russia, and positive Y is up. And when you talk about the rotation, for example, around X, you always go counterclockwise. So looking towards east, looking towards Russia, imagine you have a long axis that goes to Russia. Rotate something around that counterclockwise, then you have positive rotation. So you always go to the origin of the long axis, and then you rotate counterclockwise, then you have positive rotation. It's a good rule. Then we have X, Y, Z. With these rows, we add 3 empty columns for the phase normals, which we don't use, we don't need yet. And we add 2 columns of texture coordinates, which, well, if you have a picture, a photo of a texture, any texture, The upper edge is 0 and the lower edge is 1. The left edge is 0 and the right edge is 1. Horizontal is X and vertical is Y. So if I want a texture to fit on a triangle, apparently the first vertex is up here, so it's at X is 0.1. If it's 0 to left and 1 here, it's 0.1 halfway to right. The next UV coordinate, or the next place from the picture I want to apply on this triangle will be X is 0 to left, and the last one is X is 1. Okay, and then the Y part, 0 is up, so it's a 0, and then 2 ones, 1 here and 1 here. 0, Y is 0 up here and 1 down here. I need to tell each vertex a texture coordinate so that it can map a picture on it later on. Now I have a table with 3 rows and 8 columns, and I want to make a triangle, and I need to tell which of these vertices will form the triangle. Well, apparently number 1, 2, 3, but the index origin in 3D is always 0. So it's 0, 1, 2. By saying I have a triangle with these vertices, well, I will get one face. I could, of course, have more vertices as well, and then I could point with an index array to construct more triangles. But this is the simplest case. Create a mesh, call a set geometry X with a vertex array, a stride that is 8 columns times 4 bytes. 4 bytes is a float 32. Most in 3D is singles, not doubles, singles. A single is 4 byte. Okay, and one vertex had 8 columns, so that's 8 times 4, that's the stride. Number of vertices, that would be a 3 here, I need to tell that. An index array, that's the 0, 1, 2, and number of indices, 1. Now the mesh will get a very simple geometry. Then I set a render mode here to line. It will outline the triangle, and I make it double-sided of one specific reason. So let's see what happens here. Well, a bit of more things. I need to, I created a camera earlier. I will put it at position X is -3. Imagine that's behind your back. If you look at Russia, you look eastward. And the elevation is 0, so it's at your feet at ground level, and it's neither to your left or to your right side. And I set it to look at 0, 0, 0. That's the word origin. And that's where I'm going to place the triangle at 0, 0, 0. So I have the camera offset like 3 meters behind my back, and I'm going to place the triangle where I sit now. Housekeeping variable, draw a variable for counting time, and here is the run, is 1. You can see here while run, and it goes down here, end. And once it leaves this gap in here between, it is going to clear out everything. So run is 1, and the keyboard event may turn run into 0, which happens elsewhere. All right. Then I need to do one clear buffer because I have probably typed things, I don't know, but this is for safety. This segment here is a bit complex, so we don't need to go through that, but basically it calls the engine to fill the ref key data and ref key num memory slots, and then it takes the number of how many keys were pressed previously, last time. It's probably 1 or 0, but it can be like if you press, for example, control and a key, then it will be 2. And actually, I made room for 2 keys in this ref key data slot. There were 2 of them. The struct I will take from ref key data is 1, 0 or 1 or 2 maximum of the ref key data dot value. These were, well, I created here barref dot new 2 of this thing here in within parentheses TV key data object, which has each key data object has 3 slots, 3 numbers. It's key, pressed, or released. Well, if it's pressed, it will be a 1. Otherwise, it's a 0. If it's released, it will be a 1. Otherwise, it's a 0. The key number is between 1 and 256. Okay. So I have room for 2 key data variables here, and I query how many now got filled. And as soon as possible, I clear the key buffer, because the 3D engine is going to read the keyboard right away from this on, and I don't want to lose any of the keys that may be pressed right now when I'm here in the code. So I immediately grab the values to APL and clear the buffer, and then it may be have its own life until I get here to these rows again. If the form is focused, do something. If it's not focused, well, don't do something. It's very annoying if you're typing in Notepad and your game is reacting while you type enter. So only if it's focused, do something. And this is the bit of mumbo jumbo here, which results eventually into maybe calling the H key event for press once keys, or H key state if it was a continuous key like shift or arrow up or something. You just have to trust it will happen here. And as you saw earlier, the H key event dynamic function here only reacts on one key, number 1, which is an escape. And the H key state function reacts on 2 keys, left arrow and right arrow. These are dynamic functions residing in the same hash.sim environment. Right, so they may be called or may be called. And when they are, if they are called, they won't do anything more than mark something. And that's it. Do something with the time. We need to count time in a 3D simulation all time. We count microseconds. And the engine is able to tell us how much time has passed since we were here at this very row last time. It may be 0.00 something seconds, for example. This will grow, this t. It started with 0 here, okay? In 1 second, it will be 1. In 2 seconds, it will be 2. And apparently, I set the mesh to rotate with this number. These are radians. So in 6.28 seconds, the mesh will rotate once. Set rotation 1 will rotate it 30 degrees, and set rotation 3.14 will rotate the mesh along its vertical axis 180 degrees. So this is very simple, just to get some action. All actions are taking, all calculations are done before you actually start to render anything. Once you're ready to render, you say engine.clear to the middleware. Then you say mesh.render to get the triangle to get painted. And additionally, if you want to put in something more in the screen, like for example, if a key was pressed and you want to draw something somewhere, you can do it here. And actually, you see the variable text here, draw 32 yellow and an X and Y position on the screen in pixels and text. Well, the text actually happens here. If the left key was pressed, we assign the value, the text left, to a variable called text. And we assign a value 1 to a variable called draw. And so if draw do something with the stuff inside text, if draw is 0, which it gets each time we have done something here, and it was initially 0, then we just bypass this segment. Okay, render to screen, and we get our content to screen. Then here is a faking thing because of timing. It's not mandatory, but we need to give some time to APL, to which comes normally by other means, but this is so short, so I do it this way. End. So here is our game loop, and once we exit this loop, we are going to the, I can type right arrow ut or out. It's Swedish for out, if there's an error somewhere and I want to jump out of the whole thing. So it destroys, it unloads, and it changes space to the root. And note this very, very important thing. It deletes all stuff that we created, all variables, all housekeeping, etc. Let's try it. Reset, and it was sim1, and the function's name was sim1. Sim, sorry. Yep. These are our vertices, and it rotates one round in 6.28 seconds. And the camera is 3 meters behind, or 3 units. I like to think about meters. Behind my back. I also, when initializing the 3D engine, I said somewhere at synchronize with the vertical frame rate of the monitor. If I wouldn't synchronize, it would produce like maybe 7,000 frames a second, which is totally unnecessary. Unnecessary because a computer screen doesn't refresh that much. 60 is a good frame rate, and we produce less burden on the GPU by not creating a huge amount of unnecessary frames that would never be visualized. Now I'm going to press escape, and you recall there was one callback, the key number 1 abort. It said hash.run, hash.sim.run is 0. So I press it now, and it exited, and we are back to. And note here is no sim namespace any longer. So it's very clear. I can run and restart this over and over again. Now, this was pretty simple. What I actually wanted to do was something like this, for just for a case. This is it's a so-called Geosphere. It's a funny object. This is the simple way to make a sphere, but the problem is it's not homogeneous, and these square rectangles would consist of two triangles, so it's dumb. It's not optimized. So how do we actually do one of these in code? Well, by googling last night, it was all I coded all these last night. I learned that you start with an isocahedron. There are a lot of different hedrons, but this is a weird thing. It's a very special shape. Specifically, all vertices touch a sphere that you bake around it. And this is the geometry of the thing. And it's so regular that you can start with these to actually create the geographic sphere. And luckily, I found this wikia.org page, which says that the following Cartesian coordinates define the vertices of an isocahedron. 0 plus minus 1 plus minus rho, which is the golden ratio, by the way. And this is opens, you see right away, probably at least the APL code has that this is an outer product. 0, I have to look at it, but anyway, these are 4 vertices, and these are 4, and these will be 4. And what does it look like with the sim2 case? The sim function is otherwise identical. The defines are identical. The TV load is identical. Key handler is probably identical. Yeah, it's identical. The sim2.mesh is different. In the sim1.mesh, we created a triangle. Here we create isocahedron. I used variables here, so null is 0. 1 is, it said plus minus 1, or minus plus. And the golden ratios here, it's defined as the square root of 5 plus 1 times or per 2, and then a plus minus of them. Where is it here? Oops, wrong. Here. 1 plus square root of 5 per 2, yeah. That's in APL. That, okay, so jot.comma, and it was null plus minus 1 gold, null 1 gold, 2 elements each. Then we had something like plus minus 1 here, plus minus gold here, and null 1 0. And last one was plus minus gold 1 0 and plus minus 1. Okay. So this will create a table of 12 rows by 3. Let's see now. Yeah. 12 rows by 2, no, 3, 2, 3. And I don't remember. Anyway, the problem here is that what do you do then? Once you have the vertices, you need to know which ones to connect to get the face. And I have no idea which ones to connect, and it's such a screwed shape. You don't know what is up and down on it, and you can't get a good grip on it. So well, and I didn't want to type in them by hand, like hard coding. 1, 2, 3, 4, 5, 6, and so on. It's not going to be 1, 2, 3, 4, 5, 6. It's something else. So I thought you could, of course, take each vertex and then you test by measuring the distance to all other vertices, that which 5 are the closest ones. So you measure a distance to all other vertices, then you sort them by distance and take the 5 first, okay? All good. And here is the APL horror that actually does that. Part of the horror is that when you actually have done it for each vertex, so you have lots of duplicates. So you must resolve, for example, if you take this vertex here and you get this one and this one as 2 belonging to this. Well, when you take this vertex, you will get this one and this one, which are just were mentioned. So it's a duplicate. You get duplicate triangles, and you need to eliminate those. You only want one face connected to these 3 vertices. And that's why it's an APL horror function. It does a job, but it's not something you want to decode. It's a write once thing, but actually it creates the index array into these 12 vertices. Then we just disclose and we add, there were 3 columns and we want to have 8 columns because of the 3 normals and 2 UV texture coordinates. So we extend it towards the right to be 8 columns by a take along dimension. And then the same thing, create mesh builder and set the geometry, and we set the render mode to line to visualize a bit of what will happen. And let's see what happens. That was sim2.sim. It looks a bit like it, but you see a problem. Some parts of it come and go. And why is that? It is because each face has a front side and a back side. And normally you'd only want to render the other one. For example, imagine you create a 3D model of a house, and in the game you are never supposed to get inside the house. Then it's totally unnecessary to support that situation. So you make the faces so that the house, all the walls and the roof and whatever are visible from the outside. But if you go inside the house, all the walls will be transparent. You won't see anything. Now, in this icosahedron, the problem is some of the triangles are oriented outwards and some of them are inwards, because I lost it in that horror APL statement. It didn't. It was, you cannot bake in that much into one line of APL code. So it's not okay. And the rest of it is identical. So we need to go on, take the sim3 sample, and same start again. The key handler now supports a bit more. There's the left arrow does something, but it also sets a speed. Hash.sim.speed variable to increases it with plus 0.002, and the right arrow in fact decreases it. The up arrow alters a variable named ang, and down arrow, well, decreases and increases. So you see here in the callbacks, you just adjust values, but you don't do anything more. You prepare, and they will be used later on. The plus and minus are also in here. I seem to do a thrust named variable, bigger or smaller. Now, to resolve the faces, the orientation of faces here, I thought the one way, what if you take a point inside the object and then you calculate normals. Normal is the thing that from each face goes out exactly perpendicular to the face. And depending on whether you define the triangle clockwise or counterclockwise, the normal will go out or in from the face. Take a point here, draw from that point a line to a vertex, okay? So you have a vector coming out from the center point, and compare that line coming out with a dot product to the normal, which is either going in or going out. In either case, it will be negative, the dot product. In the other case, it will be positive. All right. You need to read on 3D to understand this, but this is how it is. So those that have, let's say, negative dot products, which here is first the comparison of normals for each face, and then from center point and blah, blah, blah. And here is actually the dot product. I seem to put into C that if the dot product is smaller than 0, then C scan int will be rotated. Each one of them will be rotated. Rotate vertex order for faces with backwards vertex order. Okay, very smart. So let's see what happens. Set and sim3, 3.sim. I seem to have also applied a texture onto this object. I'll remove that. I know where it is. It is here. Actually, I make it into rendering as a line. Here. Much better. Now it seems to be in order, and it doesn't flicker away vertices. Here you can see now when I press the left key, sorry, it was down left here. It writes left as long as I keep it down. Same with right. Additionally, I adjusted a variable with either plus or minus 0.002. and that one variable increases or decreases and affects the amount of rotation for this object. Ang, it's for an angle. Frust is for the distance. Here's the same key handler, and here I take the time. Then I take a mesh.get rotation and I set it into A, and I set it with the elapsed time times the speed, which is increasing or decreasing depending on my keyboard actions. So with this, I can actually affect the speed with which the mesh is rotating. Also, I can move the camera up and down a bit. Let's have a look at it. So pressing right, it's a bit hard to see which one it rotates. Actually, you don't know what is front and back of it, but anyway, the speed increases. Presses up, well, that too is a bit hard to experience now, but minus moves the camera closer and plus further away. But you can see that keeping keys down does action while the rendering is not interrupted in any way. Let's
By the way, you have one question in the
I do
in the Q&A that asks about, is all the simulation code in APL and the rendering done by the engine?
The answer is yes.
Good. And otherwise, I'm going to have to say that it's about time. So after that question,
yep.
Thank you, Thomas.
What you want to do is here. Do you mean I'm out of time now?
Yeah.
Okay. I will just show you the sample number 4.
Yeah.
Here. It's about subdivision. Coming here. This is the result of what we started earlier. And sample 4. And I just show you without the line system. So it's texture applied onto our nice shape. And then I'll jump off this and show the short simulation of the scientific part. This is the Copernicus, Google for Copernicus, the weather data downloaded from the European Union. It's world covering weather data. And this is with the same 3D engine and pixel shaders, of which there is one sample in the workspace that you will be getting. And you can see that there is, for example, hard wind here. And the last one, then I will be ready. Sorry that it takes some time. I change 2 parameters here and run this one. This is water currents, several gigabytes of data, and if you can see these pixels, you can see how they move in different direction between Estonia here, Finland here, Sweden here, and it's pretty cool looking to see how they change over time. So this was the scientific simulation, which is another different area to talk another hour of. So I'm ready. I knew there was more to talk than the time allowed.